Hello, I'm Tom Fischer, and this is July 12th, 2007. We're 8 miles north of Stockton alongside Highway 99 at the site of the old Pollardville Western Theme Park. And we've accepted a donation of an old historic gold mill that originally worked on Woods Creek on the tailings of the old Eagle Shawmut mine. I'm the project manager here for the North, working in conjunction with Craig Maxwell. We're attempting to rescue this equipment, be brought down to Tuolumne County, and eventually set up in an exhibit in that area, probably around Big Oak Flat. This mill dates back to approximately 1930. The equipment that we'll see here as we go on through the tour was assembled and worked by an old man by the name of Bill Leadham. Bill Leadham had worked the tailings of the old Eagle Shawmut mine probably from the 1930s during the Depression era on up until 1960, when they began to start filling the waters of Lake Don Pedro. Ray Pollard, who had founded Pollardville as a chicken restaurant, became very popular as a local attraction, began in the 1950s, along with his son Neil, to build a Western theme park. And knowing that this equipment was up for sale from Bill Leadham, this mining equipment, decided to add this mining exhibit to the old Pollardville Ghost Town. Let's take a walk over and let me show you how this equipment originally worked in the 1960s. The mill, as it's set up, is set up to process hard rock gold as opposed to placer mining. Hard rock gold is essentially gold or other heavy metals that's contained in its original matrix. I have a piece of quartz rock. There were probably 5 or 10 yards of this quartz rock that were brought in out of the old Italian mine up behind Dry Town, Amador City in Amador County. And this is the rock that was processed through this mill for tours that were given in the 1960s. The way this rock was handled was there was a large wooden bin just to my left over here. This bin was loaded with this rock that is about probably football size, maybe a little bit larger. But this rock's got to be broken down into smaller pieces in order to be processed to extract the gold that's held in matrix. The gold, for the most part, is not visible. It's all very fine. But we'll explain how that gets brought out as we go along. This large wooden hopper over to my left here would slide down through this series of rails that are all bolted together. These are railroad rails that are bolted together. The rock was fed by gravity down into a chute and with a gate on it, and this gate could be opened and closed through this hand wheel here that ran this rack and pinion. This would allow this rock to come down the chute up into a loader that there was a continuous belt that would rotate around through this loader. This would elevate these football-sized pieces of rock up into this chute to my right. This chute is aligned again with this railroad rail, which, just to give you an idea what this rail looks like, it needed to be very heavy and enduring. And so what they did is they took this rail, turned it upside down, and bolted it together. And this would provide an extremely wear-resistant surface, slick enough for the rock to be able to slide down through gravity. As the rock went down the chute into this big rock crusher, this is a Joshua Hendy rock crusher that dates probably late 1890s, possibly turn of the century. This rock crusher would take this large rock and break it down into what we call -2 inch. The crusher could be adjusted to pulverize the rock or to break it into pieces 2 inch or even 1.5 inches or smaller by adjusting the closure of these jaws that tend to open and close. And as the rock would fall by gravity through this, the smaller rock would fall out the bottom. As this rock, -2 inch, comes out of the Joshua Hendy rock crusher, it would go into a small hopper at the bottom of this bucket conveyor. This bucket conveyor then lifts the rock on up to a shaker screen. Now we're going to move to the back here so you can get another idea of what this conveyance looks like. Okay, we're getting another view of this hopper assembly that feeds this football-sized rock into the rock crusher. This just gives you another view of this conveyance that would lift this rock up into the hopper that goes into the first rock crusher. All of this is driven by belt at this point of the mill, and we'll see the power plant in just a few minutes. You can get another view of the bucket conveyors that takes this -2 inch material and conveys it over to a shaker screen, which we'll see as I move over into this area. Now we're getting up toward the head end of this bucket conveyor. that drops this -2-inch material down into a shaker screen. You'll see that this screen up here is a sieve with 1/2-inch openings that allows anything smaller than anything smaller than 2-inch material falls through the screen and down into the hopper. Anything larger, our -2-inch material, anything larger than 1/2 inch, goes into a second rock crusher. This is a Cottrell Engineering rock crusher, probably 1920s era of construction. This would take the -2-inch material and crush it up so it's now -1/2 inch. So our end result is all of our material is processed to 1/2 inch and smaller and goes into this hopper, which will then load up into our storage bin. Okay, our 1/2 inch material is coming up these buckets, all being driven by an electric motor and drive system at the head end of this bucket conveyor. This material then goes up and dumps into this large wooden hopper just up here to my left. As our material reaches the top of the head roller up here on this bucket conveyor, the material is dropped by gravity down into this bin that I'm standing in now. This bin is about 8 feet square, and it's pretty much typical of the kind of storage of broken rock that would be used before it goes into the rest of the mill. At the bottom of this bin are 2 little chutes that feed to a lower conveyor, which we'll see in just a minute. The screen here prevents this material from packing and clogging the drop down onto that lower conveyor. So the material is fed in through these little side pieces. We're going to move down to the lower conveyor and then take a look at the ball mill itself. That's the business end, and that's where the fun starts. As our -1/2 inch material is fed down from the upper bin, we go on to a very unusual conveyor belt. This belt is driven by a little transmission over here that operates a little crank. That crank causes this rod to move back and forth at a controllable speed. There's a little pawl in here that catches a tooth on this gear, and this slowly advances this belt. This belt doesn't move like you would normally expect in a continuous motion, but in fact moves through a ratchet action as this shaft moves back and forth. The material feeds off of the belt down into the head end of the ball mill. Now, a ball mill is a way of pulverizing our -1/2 inch rock down into a pulp that can be processed. At this point, we introduce water to the gold recovery process, and water is very important for the separation of the gold from its native rock and to convey it on through the rest of the mill workings. This ball mill is driven by a big flat belt, as you can see, and below us we have an electric motor that runs the flat belt on this. Everything from the stacker belt and the ore bin on down is driven by electric motor. Now, inside this ball mill, we've taken the cover off of it. You probably heard me drop the cover as I rotated it. Inside this is about a 1/2 inch thick steel walled piece of pipe, and inside are little bars. We call them lifter bars. And what they do is they tend to take the material and lift it up and drop it back down on top of itself, almost like a cement mixer. Except they would put in steel balls a little larger than a softball. These are cast steel. And these steel balls would tend to fall down on the material and crush it down finer and finer. Now, one thing I didn't point out was how the material got into the ball mill. The shaft that runs through the ball mill is hollow, like a piece of pipe. And as I turn this around, you'll see there's a scoop. This scoop, as this ball mill rotates, comes around and scoops up material out of this hopper here. This is material that's been fed from the ore bin. That every time it scoops that material up, it goes through the hollow shaft into the ball mill, where it's now mixed with water and these steel balls that are falling and pulverizing the material. As the material gets ground into a pulp, it comes out through the hollow end of the ball mill. There's a little screw assembly inside, kind of a little inclined plane, that lifts these heavier materials up and out into a piece of equipment we call a jig. Now, you can get an idea how fine this material is. It's almost like a fine sand, and you got to bear in mind this was that quartz rock that we were looking at the very beginning of this tour. And that's about the size of the material coming out of this. Now, we do have some larger pieces that have come out. Being that this is coming in a water media, that is, water is mixing this pulp up, lighter rock, stuff that is denser than gold or heavy metals, might have a tendency to work its way out of the ball mill. So we have a screen inside here. The screen allows the finer material to run down into the jig, and we'll explain the jig in a minute when we move down there. The larger material and lighter material goes down into a jig screen, that rotating screen-covered drum, and there's a spray bar that sprays water over the top of the screen. Now I'm going to just put the spray bar back up in position. You have to understand we're in the process of dismantling this mill, and certain things had to get done. This spray bar, you could adjust the stream of water going into the screen that would wash the heavier and smaller materials through this screen. The larger materials would go out the end of this. Now, the larger material may still have gold in it, but it needs to be ground out further. So we take what we call oversize off the end of the rotating screen. We drop into a hopper at the lower end of that screen and return it via a piece of pipe back to another bucket elevator, which is just to the south of this. The bucket elevator, although we have the buckets off of it right now, feeds the material back up into the head end of the ball mill to be processed even further. Let me move around, I'll point that out to you. Okay, now I'm back over on the head end of the ball mill again to point out the bucket elevator. Now, these are the same kind of buckets that we saw loading into the ore bin to my right. Although we have the buckets disconnected, this was the head end here, driven by a pulley. These buckets would take that oversized material off of the jig screen and dump it back into the hopper at the head end of the ball mill. Okay, now we're at the jig here. The jig is taking the pulp as it's coming off the end of the ball mill, and the heavier materials are going down in through a very fine screen into this container here, which has these sloped sides. Now this material might still have rust or scale to it, the heavier materials, this gold we're trying to recover. And so there's steel shot that's added along with the water and our heavy materials that have come through the jig screen. They collect in the bottom of this, and as this system is being driven by our belts and an electric motor up above, there's a plunger that's moving a rubber diaphragm up and down. And what happens here is this creates a suction that sort of pulls this pulp and steel shot up and down. So the steel shot helps to further break down these heavy materials that have come out of the ball mill. Now again, our waste material is going to come out through the top, being very much lighter, and it's going to go down into drains that take it off the property. The heavy material then is fed down over to our concentrating table. Now, on our jig screen up here, the revolving jig screen, material is being washed out by the spray bar. Anything that's small enough to get through this mesh, this also comes down onto this concentrating table. And the concentrating table is kind of a neat thing. It's almost like panning gold. In fact, the whole design of it was to simulate the action of a man panning gold. This table is mounted on stacked leaves, spring steel leaves, and actually rocks back and forth. Now this will actually go in a somewhat semicircular motion. It's all driven again by belt and an eccentric at this end of the table. The leaf assemblies, we have a piece of this one that's come off on here, are essentially stacks of spring steel that have been taped together with a friction tape to help keep the leaves together on there, and this allows this table to move back and forth with the spring action. As this table is moving back and forth, water is being introduced up at the head end. This corner of the table is lower in elevation than this section, and the table height can be adjusted through a hand wheel over on the far side of the table. Lighter materials, the sands, the waste pulp, is washed over the riffles down into this collection trough and goes off into the waste stream off the mill. The heavier material, the heavier concentrates, form over at this corner and are then fed down into a small trough at this end of the mill. In the way this was set up, that trough then fed through a piece of hose over into a second concentrating table. And this is where things get even more interesting. Now I mentioned that this first concentrating table could be adjusted in height and tilt through a hand wheel, and here on the table here. As these concentrates have come off of the first table, we go into a second table, which is really kind of an interesting little thing. These tables were built by the Straub Manufacturing Company in Oakland, California. Straub was one of the major mining equipment manufacturers, And this was neat. It was driven by a belt. You can see the old belt right here. And there was originally an electric motor above my head, about 7 feet from the ground, that drove this pulley. Now this pulley, if you look at it, is a cast steel pulley that has a lot of weight up on one half of it and no weight on the other side. So what happens as this table, or this pulley rotates, it imparts this oscillating motion to the table. This is how we get that rocking motion that I was talking about. Again, just like the big table, our heavier materials tend to follow along the riffles down to the lower corner of the table. This table is different from the first table in that it's clad with copper. This is copper sheet down here, and this copper sheet, when it was cleaned, would be coated with mercury to form, with gold, it would form an amalgam. Mercury has an affinity for gold and causes fine gold particles to bunch together almost like a paste. And when this amalgam is heated, the mercury would be evaporated off and condensed to be reused again, leaving a gold button. So again, although our lighting and the dirt here may not make it very evident, this is copper underneath this table. Lighter materials come off the top of the riffles down over into the waste tray. Heavy materials drop down to the lower left corner, down into these little troughs onto a sort of an amalgam table. There's carpeting up here at the top which would capture the bigger gold, anything you could pick. The fines would come down into a secondary copper sheet, which, like the table, was also coated with mercury. And here, anything that escaped through the further process would be captured. Waste pulp was collected in kind of a crude trough at the end on here and fed out the waste stream of the mill. That is essentially the equipment and how it operated. Now, we started out earlier in this tour here with the rock crushers and the conveyance system to get our rocks from football size down to -1/2-inch size. What we didn't discuss at the time was the belt drive system. I'm standing in front of a jack shaft. This is sort of an intermediate pulley system that has pulleys going off to the first rock crusher, off to our second rock crusher, on over into the bucket conveyor between those two crushers. And the drive power for this portion of this mill is on this 1927 Cletrac tractor engine. Essentially what they've done here is just taken the tractor frame and cut it off and then put in an extension shaft with a belt pulley on the far end that would then drive this whole mechanism. Belt drive was very easy to set up, and it could be powered by anything from a Cletrac tractor engine to the rear axle of a Model T Ford. And anything in between those two extremes. This engine is probably runnable. One thing we hadn't mentioned was the last time this mill had operated. From what I've been told by Neil Pollard, it was probably sometime in the middle 1960s that the mill last operated. At that point, it became more of a display artifact rather than a functional mill. Bill Leadham had been brought, as I had mentioned in the very beginning, had been brought up from Tuolumne County to orchestrate the assembly of this mill. And after about 10 months on the project, Bill had been injured. Whether he injured his back or had an illness, we don't know. Bill was up in his middle 70s at that time. We just don't have any real history of Bill beyond that. The project was finished up by Neil and apparently another person who was knowledgeable enough to help put the building structure up around this equipment once the equipment was placed. Well, that's pretty much it for the tour of the machinery. Thanks to the volunteer efforts of some very expert and talented Tuolumne County residents, myself, and support of the Tuolumne County Board of Supervisors, we hope in the near future to reassemble this mill as a meaningful interpretive artifact of gold mining history that was at one time a part of Tuolumne County. Thank you.